Test sound 1 and 2 and 3. Hi Ahmed. Okay, I think we are live on Twitch, on YouTube. So let's solve some problems. Long time. I'm streaming for the past few days. Also, I already announced the Huawei IOI camp. So if you're an IOI participant or coach this year, check it out. It's free. And for others, well, there will be recordings later, so you can attend. You can eventually watch that. But non-IOI participants cannot participate. It's not open for everybody. Otherwise, there would be very big range of levels. Also on Discord, I cannot make a call with arbitrary number of people. Stream every day? Not every day, but when I have time. When I have time, it will be a few times a week. In particular, I think I have time this week. The IOI camp will start on 17th of July, so a week starting from that day, I will not have that much time. In August also I will do some paid classes, so I will not have that much time. When I do code for solid code, do you know solutions or how to do it instantly, or is it because of patterns? I mean, you can see me solving problems, so you see how quickly I come up with it, and I try to say my thoughts out loud. So just, you can I don't know, take from that whatever you want. Okay, did I do those problems? No. This seems complicated. So maybe not. What else we have? This round, I solved some problems, skipped one because it seemed ugly. What about this? What is this round? Division 3. I guess I skipped those, right? Actually, that one doesn't seem so bad in terms of the statement. Let me read. So maybe this task, I'm not sure yet. Any suggestions for doing DSA in Java? No. Why I don't post on Code Forces? When I have stuff to post, I do it. We have a binary string, 2 players. Alice wants to turn everything into zeros. If Alice cannot achieve that in finite number of moves, then Bob wins instead. In Alice's turn, she chooses subsequence of length k and changes all characters to 0. In Bob, chooses substring of length k and sets all to 1. So after Bob's turn, there is always substring of length k that is all 1. And Alice, what she wants to achieve is that only that thing is that. I think intuitively Alice wants to take zeros from the sides. So if there is a string that looks like that, and now it's Bob's turn, for big enough k, no matter what he will do, he will include this one. So what Alice will get is just this thing where there is a substring of length k with only ones, and Alice will turn everything into a 0. Okay, Med Anime, I'm blocking you, sorry. Too much spam for the past few streams. Will this problem be on YouTube as video? Well, not this problem particularly, but the whole stream is also on YouTube. Yes, I am married. Alice starts, right? Yes. So I think that we should do something like this. Alice might win in the first move, and we need to check that separately. And then a second thing, for short enough string, it seems that Alice will take things from the sides. Because what if, for example, string length is 9, k equals 5, and we have this situation where only the very middle character is 1, and now it's Bob's turn. One more 0. Now it's Bob's turn. He will include this 1, so for sure he will leave only 5 characters as a 1. So this seems to be an important condition. Alice will usually take stuff from the sides and turn to 0. Bob will do it in the middle, but without including existing ones. So maybe it's important whether there is a 1 that is far away from the sides. So, okay, I have the following lemma. If there is at least one that is far away from the beginning or the end, so for example this is of length k, this is of length k, and this is a one that is further away, Bob can turn all of that into ones, and then Alice will turn all of this off, or maybe no, Alice will turn everything here off. Alice will change this one into this one. Will there be IOI camp? Yes. I already posted on Codeforces. Maybe in the chat I will paste the link with information. IOI camp for IOI participants. I'm sure that the code for this task will be very, very simple. Just a few checks. So it seems that it's not very important that this is the one because Alice will take care of it anyway. So maybe it's just a comparison of lengths. Maybe we need to simulate this game, kind of. We need to maybe figure out the exact optimal move for every player and simulate for O of n turns. Interesting. I see that Decoding Tech earlier asked, can we use stacks here? Well, stack is a tool. So when you see a problem and you don't know a solution, it's usually not a good idea to first think about data structures that you can use, unless you're speeding up something particular. You already have a working solution, now you want to do it faster. Then there might be a data structure that can do some operation fast, instead of doing it linearly with a brute force. But so far, I don't have any solution. Maybe I could come up with something exponential, but that will not be very useful here. Red, I think I saw your message on my phone. I mean, via email or something like that. I will reply to you later, but I'm guessing not. I'm guessing that I don't want to do problem setting for a competition different than big code forces round that I would organize myself. Well, if the string is very long and there is a single one, at least one, then Bob will do something like this somewhere in the middle. There will be k plus 1 once. Oh, actually, this is very important. Can Bob always make a move that, such that there is a 1 that was already existing and it's not included right now? And if this is the case, then it's always possible, because we can look, if the string length is 10, or maybe, let's say 6 versus 3. If you have a string of length 6, there is a 1 somewhere, there is for sure a possible move, a range of length 3, such that we will now have 4 ones. So there will be a subrange of length 3 that doesn't include this single 1. And now if this is the case, there might be a 1 here, and but after we make a move here, Alice will turn off, let's see, the stuff on the sides. So Alice will leave this guy. Maybe this is turned on, this is turned on. Then Bob will turn this on. Then Alice will turn this off, and no. Alice wants the middle stuff to stay. Alice will turn off this, and that. Okay, I'm guessing that it's only now important if string length is greater than twice k. And if so, Bob wins, else Alice wins. Now, I'm not sure about it, but it's simple to code. So let's see if it works for the sample tests. Maybe it does. And if not, I will not have a counter test, which is also helpful. First, we check if Alice can win immediately. For every character in S, if this is a 1, then count plus plus. And if the number of ones is at most k, then Alice can turn them off immediately in the first move. So we return Alice. Else we do it based on this, n smaller than twice k. Else print Bob. Maybe I should have guessed the condition earlier, because it's so simple. I think very quickly I had some idea to look into this 9 versus 5 size, that this is something special where the middle character matters. Twice the number of ones? Really? If what Fritimam says, then my solution is incorrect. We'll see. No, accept. Okay. Then, very simple logic. The number of ones needs to be at most k, or the size needs to be less than twice k. And the reason for that explained as I went through my thoughts, but I don't really have a full proof. So I think we can leave this. I didn't find this problem very interesting. Should we maybe do this one just to be done with the first, with prefix of this contest? But do I want to do that? Blackboard game. There are numbers from 0 to n minus 1. Please explain that. Okay, well, the reason to compare this at all was that if we have string of length 6 and there is a 1 somewhere, anywhere, and now it's Bob's turn, Bob chooses range of size 3, k equals 3, let's say. N equals 6, k equals 3. Then there is this very simple lemma or observation that Bob always can choose something that is disjoint with the existing one. So if there is at least one 1, then Bob can choose a range of k new ones. So Alice gets k, at least k plus 1s, k plus 1 ones, so cannot win, and leaves at least 1 1, and the process continues because Alice turns off only k digit ones, digits equal to 1. So this was the logic, and this logic doesn't really work if there is a range of size 5, for example, and k equals 3, because if the remaining one is here in the middle, then Bob will cover it. So Bob choosing range of size 3 kind of wastes this opportunity of having a 1 there. So Bob will leave only the range of size k filled with 1s, and Alice will be able to turn it off. So it seems that this one is actually useless. We can treat it as a 0, kind of. And for remaining bits, 1 by 1, Alice will be able to turn them off, because Bob chooses some range of size k, and Alice will then turn off those k minus 1 digits. Alice will not care about this one. So actually only k minus 1 digits, and one more digit, something from here. So eventually, she always will negate the move of Bob, ignore the middle digit, and instead of that, turn something off elsewhere. Eventually, we will be left with this single one here. It's Bob's turn. He will paint something. There will be k digits 1. Alice will turn them off and win. That's the explanation. If k is greater than n over 2, maybe you wanted to say smaller. Yeah. Yeah, right. As I said, I will reply to you later, but I don't think I'm interested. There are many contests out there, and organizing any contest, creating problems, it's very time-consuming process. I do it like once a year or something like that for some big Polish competitions, and that's enough for me. What I did actually in university is just to earn money. I used to problem set a lot for Topcoder, for example, but Topcoder really, they paid a lot. It was close to $1,000 for creating a full round, and it was just a few problems. It wasn't that difficult. Wait. So, we have not solved this problem yet. Let's look at it. Blackboard game. Numbers from 0 to n minus 1. Alice chooses an integer a on the blackboard and erases. Bob chooses integer such that the sum modulo 4 is 3. So like 0 can be paired up with 3, 1 with 2, 2 with 1, 3 with 0. Determine who wins. Okay, I'm not fan of this kind of problems because they are just about math analysis. But if n is divisible by 4, or actually n, yeah, n divisible by 4, then numbers will create perfect pairs, and Bob can always respond. For example, 0, he will respond with 3. 3, he would respond with 0. 1, respond with 2. 2, respond with 1. So then Bob can always respond, and eventually Alice loses. So Bob wins. And otherwise, I believe that Bob will run out of responses. Does it work for samples? Bob wins for 4 and 100. Yes, that works. So int n, read. If n modulo 4 is non-zero, print Alice, else Bob. What I'm using here is called ternary operator. If this is non-zero, then do that, otherwise this. Okay. Topics required in beginning to increase rating. Solve problems at your level and see what topics you encounter. Yes, if n modulo 4 is 0, then Bob wins. That's exactly the solution. Okay, and just to get this, those 5 problems, all of them, what is this? Yeah, sure, red. Given array of distinct integers, you can choose prefix and replace everything into the minimum value of that prefix, I guess, and choose suffix and change into, and change everything into the maximum. You can choose the entire array. For each element, check if, oh, you don't change everything, you erase. So you erase everything except for the minimum, or everything except for the maximum. For every element, check if you can do a series of operations to get only this single element. I'm guessing from those answers that the answer is monotonic. So it's true for some prefix, and then it's true for some suffix. That's my guess based on that. I'm not sure about it, but I think so. Please try solving a LeetCode contest once. What I'm going to do is, starting from next month, I will do that as part of paid group classes. So it will not be public stream for free. Maybe I will get back to streaming some stuff about LeetCode problems. Not in the next week. Stop repeating your questions. I told you, solve problems at your level, and you will see what topics are there. Okay, how do we achieve stuff? So the minimum in the full string or sequence can be achieved because you just choose everything, you say I'm changing that into the minimum. This is the maximum. Okay, here's my guess. I'm too lazy to analyze stuff, but I think minimum and maximum are possible, and maybe just everything after maximum and everything before the minimum. I think it works for those samples. So I'm not going to think, because guessing properly and using intuition is also part of contests. I'm just going to code this idea of mine. There can be ties. No, it's distinct integers. We need to find the minimum. Let's call this mi. If minimum is, if a of I is smaller than minimum, then this is minimum. If greater than maximum, then this is maximum. And I wonder what happens if minimum is to the right of maximum. But I'm guessing that then everything will be possible. If index is smaller or equal than minimum or greater or equal maximum, then print a 1. Actually, you can just print this. It will print a 0 or 1. So I think here it's worth, even in a contest, I think it would be worth submitting this without thinking, because there is a chance that it works and you save a few minutes of thinking time. It doesn't work. So I think it's time to start thinking. Yes, they can overlap. Then my solution, I think, will just print only once. One test case, n equals 5 for, let's say, 3, 5, 4, 2, 1. Yeah, then only once. Okay, I did something wrong, so I think we need to analyze that. How do we achieve the 2? So why is this possible? That's because for everything here, we change it into the minimum, and then this guy eats that minimum. So what about this? A number is good if we collapse everything to the left into the minimum of it. We collapse everything here into the maximum. Because why not? Then we want to win with x. So x, well, or maybe I think x needs to be greater than stuff on the right or smaller than stuff on the left, but isn't then this equivalent? Not really. But here's the thing, if x is greater than stuff on the right, so let's say x is 6, and there is bigger stuff, like there is 8, but this is here, then applying minimum here will eat the 8, as long as there is something small here, like a 2. So here we will survive. Applying from the left minimum again doesn't make sense because 2 will eat a 6. But applying max from the right, we compare with this. So I think what we want is AI to be greater than suffix max on the right and any other condition. And also it needs to be greater than prefix min. If this is true, then we can succeed because the minimum changes into, prefix changes into the minimum. We get rid of bigger values here. And now we apply the max on everything, and we want AI to beat the suffix, and in the prefix just beat the minimum. I think that's it. So I'm going to compute prefix and suffix minimum. For that, I'm going to read from 1 to n because using such indices is actually more convenient for prefix and suffix stuff. As you go from left to right, you want prefix minimum. Pref min of I is minimum of pref of AI and previous pref min. The first pref min is some kind of infinity. And now go the other way. Suffmax. That's done, and now I want to write this condition. If I is greater than both suffix max of I plus 1 and prefix min of I minus 1. If this is the case, or something symmetrical, I will try to do it symmetrically. Smaller than I think it's simply this. So if this, then print a 1, I'll print a 0. Not sure, but I'm going to run it on samples. Out of bounds. We want to do this from 1 to n, because that's the indices I actually use now. Works for the sample test. And again, I would say worth submitting, because if something is wrong, I cannot fix that in a minute. It means that it's possibly very wrong. If you think it's incorrect, it should be like that. Let me analyze again. I want here, I will change the prefix into the minimum. And then what? Suffix into the maximum. And then by doing the prefix or suffix operation, I want this to win. So it needs to be extreme. It needs to be greater than both or smaller than both. And I think this is exactly what I'm doing. There might be other ways to implement it. There is point or time penalty in the round, so does it make sense submitting such easy problems without proof? I mean, it makes sense submitting greater or equal, but there are no ties. Yeah, and to answer the strategy question, well, almost never you want a full mathematical proof because it takes a lot of time. So it's a trade-off of how close you want to be to a full formal proof. And here I decided to be very far away from it. And now you're saying that there is penalty and so on. Yes, but also spending more time on a problem will decrease my points for this problem and everything forward, and all the following problems. So I would argue this. So maybe first, observation. Every minute extra spent on problem A costs more than a minute spent on problem E, for example. Because spending extra time on problem A moves or increases your submission time for all the following problems. It doesn't matter what is the score of problem A versus problem E. What matters is that here you decrease your points for the problems A, B, C, D, E, F, G. And here you only decrease the points of problems E and onward, so maybe E, F, G. And because of that, usually what I do during contests is I actually take a slightly bigger risk submitting or solving easy problems. Also because since the problem is easy, it's more likely that my wild guess turns out correct. Train to make correct observations, solve problems. You will learn patterns this way. Learn how to make observations. The stream today, by the way, will not be very long. I will finish in 40 minutes. Is it optimal to do something else? Wait, if AI is smaller than the prefix minimum, so like this, then we can apply the operation of applying minimum here. We obtain a 2. And then we collapse this into the maximum, and we have then 2 numbers. And depending on the comparison between them, we will either do the minimum of them or maximum of them. So actually, if this is smaller than that, then we always win. Always. So I will say if AI is smaller than prefix minimum or greater equivalently to suffix maximum, or now is this stuff necessary? Don't we repeat this stuff? I think maybe we need to now remove that and just go with this. Well, now during a contest, I think I would think a little bit more, because getting multiple penalties, that starts hurting, and also I spent a lot of time. Oh, but we passed test 2, so I think we're okay. Yeah, I overcomplicated the problem. So it was simply, this is equivalent to saying AI is prefix minimum, and this says AI is suffix maximum. Because if any of those is the case, then such prefix or suffix you can turn into just this number. The remaining suffix or prefix you turn into something. And once you have 2 numbers left, you can choose any of them to be the final one, just by applying minimum or maximum. Okay, I think that's done. And that's the end of Codeforces Division 3, 1034. I will read this statement, but I don't think I will do it. Permutation, GCD of I and PI greater than 1. So it's like some kind of matching. It's not necessarily matching itself, but we want to pair up values from 1 to n such that they have a common divisor, but we try to avoid pairing a number with itself. I would call that a constructive problem, kind of. It's even marked as constructive. But I don't know how difficult it is. Anybody recommends it? Solve F2, it's pretty easy. How is MNBVMAR doing these days? He's fine. He doesn't do competitive programming though. Okay, we can try that, but I might give up. So basically we have numbers from 1 to n, pair them up, or well, create pairs. Actually we have indices and the numbers. Have two sequences of numbers 1 to n, create pairs between them. So basically matching. Every pair needs a common divisor. Minimize the number of pairs x, x. For example, if we have those numbers, I want to pair them up. 7 needs to be combined with 7 and 5 with 5. Those are primes, so I cannot do anything about it. 1, what about 1? We don't care about 1. Okay. Now 2, 3, 4, 6. I think 2 combined with 4, 4 with 2, 3 with 6, 6 with 3. So now I achieved that with just 2 bad places. And I cannot do anything about them. And there is also a 1. One, 2, 3, 4, 5, 6. Here they combined everything except for the 5, which is the prime. 13, 11, 7, they are impossible. Everything else is possible. Now, what should be the logic? So primes at least primes greater or equal n over 2 are alone. Well, greater than n over 2. Depends on how you round. Because those there is no second prime there is no second number that is divisible by this prime. For example, when n equals 100 and you look at a prime like 53, nothing else up to 100 is divisible by 53. Hi, Dad. So maybe always everything else we can combine into pairs. 3, 4, 5. Here I think it's true. It's true. Well, here it's also true if we treat n over 2 as a real value. Maybe we'll start from highest primes. So iterate primes up to n over 2 decreasingly. For each, collect its multiples that are not used yet and use them. I think we will always have at least 2. That's my theory. Because you will in particular have this prime and this prime times 2, because it wasn't analyzed yet. And maybe some more. For example, if n is equal 100, when you get to a prime equal to, say, 11, at least what you will have is 11 and 22, and maybe some more. Why do you have those two? Because you did not yet get to prime equal to 2, which would also see this as the multiple. If p is 7, then at least we will see 7, 14, and so on. If p is 2, then at least we will see 2 and 4, and 8, and so on. Now to combine them into pairs, when you have, for example, 7, 14, and 21, let's say, you can say that 7 matches with 14, 14 with 21, 21 with 7. So like it's a cycle. Combine something with multiples except 2. I think that we don't need to do anything special for it too. So yeah, I will do exactly that. Do I need prime sieve? It might be useful. Is prime of n plus 1. By default filled to true. For every value up to n, if is prime, then iterate multiples. This is false. Okay, we have that, and now iterate primes decreasingly. In particular, automatically I will see which ones do not have anything to match with. And now I will have a visited or used array. Here collect stuff to something like that. For every multiple again, no, only do that if prime. For every multiple, including this number itself, if not visited yet, then visit, add to the vector. Now I collected all unvisited multiples of this prime, and now I'm going to match them into a cycle. Answer of v of I equals v of I plus 1. This is some kind of vector. For 1 the answer is 1, and I think we can just print it. And we didn't read. Two goes to 4, 4 goes to 2, 3 goes to 6, 6 goes to 3, 5 goes to 5. That's reasonable. Try submitting. Yeah, so the problem indeed was quite easy, I think. Prime sieve might not be necessary, but I think prime sieve is not really harder than finding divisors in square root. So I'm fine with this. Anyway, the main piece of my logic relies on sieve-like logic. So as well, I can earlier repeat that thing where I iterate primes and I iterate the multiples. I don't think I could have coded that in significantly shorter way so that I would code for more than 1 minute less. Now, in this division 3, we solved everything except this, but I think the last problem in division 3 might be very annoying and very standard. I will read, but I'm almost sure that I will not. Did I not understand line 10? line 10. Well, this is prime Sieve. Look up this term, prime Sieve tutorial or something. Let's read G. Assign a single value like that. Increase something plus k modulo m. M is given. Check if you can make a non-decreasing. I think that GCD of k and m will matter a lot. In particular, if the GCD is 1, then you can do whatever. The limits are very low, 100,000, and the time limit is big. So I'm guessing already that M is big. What was M? The modulo. I'm guessing that we might need to use square root decomposition. If you started today, how fast would you become legendary grandmaster? If I started programming, if I was very good at math already, maybe 4 years, if I trained a lot. No, I think that's not true. If I only now started programming, it would be more than 5 years. Okay. So if GCD of k and m is 1, then we can achieve everything. And the answer is always yes, we can do it. For example, if we do things modulo m equals, I don't know, 10, and what we have is k equals 3, then by increasing something by 3, we modulo 10, we will go through all the values out there and eventually cycle back to 0. So by adding 3, we can change a value into anything we want. Oh, I have an idea. We will investigate all the divisors of m, and for each of them we maintain something. No matter, the value k does not matter that much. The value GCD of mk matters. The exact value of k does not. The values of GCD, the possible values, are only very few. So for each divisor of m, and only all those can be GCD, we maintain a data structure. Now I think I understand why the time limit is big, the constraints here are small, because number of divisors of m is relatively small. Usually we assume it's cubic root of the number. The number of divisors of m is roughly cubic root of m. It's not actually, it's not correct thing to say, but for the sake of competitive programming, we can say that. It's good enough estimation. But what is proof of what? The claim is, if you can increase by k modulo m, you can achieve everything with the same divisibility by GCD. Let's call that basic algebra. For example, if m is 10 and k is 8 or 6, I achieve that starting from any number, you can reach any number of the same parity. For example, if you start from 3, you will get all the values that are odd if you keep adding 8 modulo 10. I guess you can analyze that using Euclidean algorithm or something like that. Timed out in PyPy for me. in non-trivial problems, I think Codeforces only officially guarantees Codeforces solutions to work. Other languages, you're on your own. Now, what if this GCD is not 1? Then for every element, its value modulo that is important, and its comparison to the next one is important. So let's say that GCD equals 5 or 10. I think 10 is a great example. If GCD is 10 and the first number in the sequence, and m is equal to something big, say 130, doesn't matter. If the first number in the sequence is 27, then actually we can think about it as a number 7. So if then in sequence A we have 27, in my data structure I will actually have a 7, because I decreased it by 10 multiple times. Then let's say next we have 59. I decrease it to 9. Say that next what we have is in the input sequence 32. I decrease it, but not to 2, because that would be decreasing. I decrease it to 12. So always, it's important that here we have this drop. This had bigger value modulo 10. So for fixed GCD, it's very important if AI modulo GCD is greater than AI plus 1 modulo GCD. If I see this situation, it means that I need to like jump to the next multiple of 10. Like those values, they were in range from 0 to 9, and here the values will be now in range from 10 up to 19. And I have only 13 such ranges. If I start from values that are in range from 0 to 9, I cannot exceed 130. So later, if after 32 I have something with, let's say, 8 as a second digit, I will use here 18. So I'm still at the same first digit, at the same multiple of GCD. But if this instead was something 1, some 2-digit number with a 1 next, I would need to jump up to 21, so that it would be greater than previous element. So I'm going for every GCD, so for every divisor of M, I'm going to keep track of the number of places where this happens. I think normally during this stream I would not code it, but I will at least finish this Codeforces division 3, so I think I'm going to do it. Okay. So summary, for every divisor of M, which is possible, so this divisor is a possible value of GCD of M comma K. For every divisor, what I do is maintain the count of places where this happens. And then for a query, compute GCD of MK, and for this divisor, for which we maintained, check the count of those places. The thing that you maintained here, you have access to that in constant time. And what do? We check if we have enough. So check if this divisor multiplied by places doesn't exceed M. Maybe smaller equal. Let's think. So like, let's say that M is 30. Then how much I can afford? I can afford 1 increase and second increase and no more. If I have 3, then I lose. So it needs to be smaller. Like 10 times 2 smaller than 30. 10 times 3 not smaller. Okay, that's the solution. Is any guy rated smaller than 1600 expected to solve it in the contest? Well, I don't fully trust those difficulties, but if this is 2100, then this is significantly above your level if you are below 1600. But also, if there is a contest and there is last problem, they try to make it in such a way that it is a challenge for the best people, for the top few who officially participate and are allowed in this contest. So, 99.9% of people are supposed not to solve it. And standings should reflect that. At least the official standings, if we exclude people outside the division 3. So here what we have is that 30 people solved it. Among how many participated? 15,000. So, 99 point something percent did not solve. Also, some people might have their rating too low because they didn't participate in enough contests yet. For example, this person, if you look at the rating graph, most likely we can guess that he will keep climbing. So actually his current rating is undervalued. Okay, let's code. Let's code exactly this logic. What do we read? NMQ. The array. I will use indices from 0 to n-1. Then there are queries. If type is 1, then read the index and the new value. Decrease the index by 1, a of I becomes x. Else the type is 2. And what do we read? K. Okay, divisors. For every value from 1 up to m, well, k is smaller than m, so m itself shouldn't be considered. Can m be 1? No. If m modulo d is 0, divisors push back m. No, d. Now for every divisor, or maybe I want to first verify my solution for samples with a brute force. So actually what I'm going to do here is d equals GCD of mk. Does it compile so far? Yes. I'm going to verify using this. So count those places. Fi modulo d greater than fi plus 1 modulo d. If this is the case, then count plus plus. And what? Divisor count times count smaller than m. Just in case long. I'm not sure about the overflow here. Print a yes, else and no. Now, in just 1 minute, I think I coded that. I can verify if my logic seems okay, and then how to do it fast, I will do separately. Seems fine. Now, sometimes in some competitions like Olympiads, it makes sense to submit this code because you will get some feedback, some verdicts on small tests, but in Codeforces usually you will get time limit exceeded on test 2 and you will not get much information from that. What do you think about the rating of division 3 problems and so on? I have no idea. I would really need to spend few hours comparing a lot of problems, and then I could tell you. What you can do, if you want to really analyze it and compare the difficulty of division 2 versus division 3 problems, find people who are participating in those, and like in all of those, compare their solving time. Most people solve problems one by one from left to right. So for the majority, you can see how much time they spent on a problem, and you can check if 1600 rated problem in division 3 took the same amount of time for people as 1600 problem in a division 3 or division 2. It was always enjoyable watching your stream without understanding it. Maybe one day you will start understanding them. I did math in childhood. I didn't do programming in childhood. Okay, so we passed the sample test, right? Yeah. So let's now do it fast, which is I want for every divisor to maintain this information. For every divisor, let me maybe go full screen for a moment. Count plus equal this. Count of that divisor, or answer for that divisor. So it's pre-computed. And now, after we have a modification, I need to do this. If now I need to update how I interacts with the next index. If I plus 1 is smaller than n, then I need to do exactly this with a minus before the change. And after the change, add it back. Additionally, if I minus 1 is greater or equal 0, then for every divisor, what I need to do is cancel the influence of AI minus 1 modulo d greater than this. And after the change, I add it back. This way you basically avoid ifs for what was the comparison before versus later. I'm not saying this is the best thing out there, but it's something. Now I'm not going to here count it again and again. I'm going to just say answer of D. Does it still work? Also, I should have copied that previous code with that, so that if I get wrong answer, I can stress test. I do that during competitions. When I have a brute force, I copy it to another file because it might turn out useful later. Missing your dog. The dog is there. Running on test 8. What's up, dog? Wide number of divisors is roughly cubic square root. Oh, interesting. Hinam, there is no explanation. That's not scientifically or mathematically true. It just happens to be a good estimation for values that we use in competitive programming. For values up to million or billion or 10 to 18th, it's a good estimation, but that's it. No limit on sum of m. Then again, second time during like 3 days, I lost because I focused on the single test case. Okay, then I think I'm getting time limit exceeded because of this. And if that's the case, what I want to do is, first of all, create that answer array once instead of multiple times. Here, for every divisor, answer of D set to 0 initially. And finally, I cannot afford to do it again. Can I do it in square root? I think I can, right? 10 to 4th times square root of that. Yeah, that's less than 10 to the 7. Okay, so here. I think now now this became square root of m in time complexity, not O of m. So for big M, it's not that single test case is so slow. Thank you, Jerome, for telling me the reason for this time limit exceeded. I just stored all divisors globally. That's all. That's actually what I wanted to do just before thinking about this. But if possible, I want to do test cases independently. I think that this is slightly safer than doing it outside. Well, it's not really significantly better. Yeah, I don't think one method is way better than the other. But we have accepted 1 second out of 5. Instead of this, I could also, in main, run prime sieve, save all divisors. That's mlog m memory, which sometimes is an issue. Also, when you push back to vectors, you have twice more memory. So, you know, this much times log of it times 2 times int. How much is that? And some people define int long, so it will be times long. This will be 20 million times int 80 megabytes. Then that's okay. 80 megabytes doesn't exceed 250. But, you know, it's not far away from exceeding that. Also, a lot of memory does consume some time. So if this was 1 second, then I would worry about only this preprocessing part already taking significant amount of the full time limit. The complexity is that. Let's analyze the time complexity. For a single test case, what I have is of n plus square root of m. I read n stuff. In square root of m, I do the divisors. Then here I have n times the number of divisors, and then there will be q also times number of divisors. So n plus q times number of divisors, which roughly should be estimated like that. There is GCD computed here, so q gets multiplied by logarithm, but that's smaller. Still, well, log of something, I don't care. I often, in competitive programming, most of the time you shouldn't even analyze its logarithm of what, because it doesn't matter. Here I think it's logarithm of m. That being said, you're wasting time by thinking about it. It's logarithm, whatever, maybe it's 20, maybe it's 17. And q times cubic root of m is greater than that part, so this part kind of you can skip. So you have this per test case, and you are guaranteed something about the sum of n and q. This gets multiplied by the number of test cases though. So it's O of t times square root of m plus sum n plus sum q times cubic root of m. That's the full time complexity. Shana Mario, you're asking hard questions. I don't know. I don't know how long it would take to become expert if you're not good at math. To be honest, I don't know if maybe better question would be what percentage of people would achieve that. Because if you're terrible at math, if you're very bad, you're just not talented for math, then most likely the answer is never. You will never achieve expert. Why there are few women in CP compared to men? Maybe many of them do not even attempt it. I will not explain the GCD again because this is a harder problem, not a good one to practice this property of what happens with increasing by a k. It's some kind of math, some kind of algebra, that property with GCD. Generally, if you didn't know about that GCD thing, then this is generally a problem that is too hard for you. Okay, but what we achieved is, yeah, the green color. That's nice to see. I don't know when, I don't know how far I would need to scroll to see that. I mean, if I scroll very far, if I get to contests where I actually practiced a lot, then I'm sure we will see a lot more of that color. Six problems. When did I practice a lot? Also, I need to go around 500, around 400. So this is roughly when I practiced a lot. Well, there is a lot of blue, like solved 3 out of 5. 4 out of 5, 4 out of 6. I didn't absolve enough, I would say. That's bad. I expected a lot more of the green color. But it's nice to sometimes see it. Oh, I was second? I thought that I was second once. Contests, and it wasn't after Umnik. Sort by rank. Oh, I was second twice. I was third 3 times. I was fifth 4 times. It's so sad that I was in the top 10 so many times, and almost all of that is Division 1, and I never won. And here I lost by 1 minute. Look at this. With this guy. Same time. 6 minutes, 6 minutes. 18 minutes, 18 minutes. No wrong attempts. 33, 33. And then we attempted 2 different problems, each worth the same amount of points, or number of points. 129, 130. I lost by 1 minute, and because of that, I will never win a Code Forces round. Because now, I'm like 5 years after my prime. I'm too weak now. My chances are very, very, very low. I'm sad about that. So close. That other contest where I was second after Omnic, I don't think I was particularly close. Well, he would need to not participate. That's it. Okay, I need to finish the stream because I have something at 3:30. Sorry, at 4 p.m. So I don't start again. Thank you very much for attending the stream. Next one either tomorrow or in 2 days. Why you think your prime is over? I'm weaker now. I don't practice. Do you want to show your face to the stream? No? You're shy? Maybe next time. Okay. See you everybody. Thank you for attending, watching. The IOI camp is already announced on Code Forces. I will announce the paid classes later on. Maybe tomorrow.